Living in the modern world can often feel overwhelming. Looking out the window will show you beautiful ecosystems that are torn apart every day. Pollution is ravaging the environment and is even making water undrinkable. Invaluable species like bees are dying at an alarming rate. Looking at our community, we see devastating illnesses like dementia and cancer. 20% of adults in the United States are suffering from mental illness, and without even covering socioeconomic conditions, it's easy to see why. Now what if I told you there may be a single solution to all those issues? Fungi. Paul Stamets is a mycologist that has spent over 40 years making groundbreaking discoveries in the field, but let's go back to the beginning. Stamets was born in 1955 and grew up in Columbiana, Ohio. Growing up, he had a stutter that he was extremely embarrassed of. He would often not make eye contact and stare at the ground most of the time. He couldn't help but notice mushrooms. At the age of 18, Stamets bought a bag of psilocybin mushrooms that weighed roughly 20 grams. Not knowing the proper dosages, he ingested all of them while sitting in a tree he often hung out at. As he got higher, he noticed a large thunderstorm brewing, seeing fractals and lightning and describing the atmosphere as liquid. After what he called a beautiful, indescribable experience, it occurred to Stamets that he was in the tallest tree on the tallest hill for miles, and he could die at any moment. Being unable to leave, Stamets decided to reflect inward and get something out of the experience. He kept telling himself, "Stop stuttering now," repeating it hundreds of times until eventually the storm had passed. Since then, the stutter has never returned, and experiencing neurogenesis from mushrooms led Stamets to devote his life to studying the medicinal properties of all fungi, not just psychedelic mushrooms. In 1980, Paul founded Fungi Perfecti LLC, and he makes sure you know it's pronounced that way. Since its inception, Stamets has produced research that, with more testing, could improve mental and physical well-being as well as restore ecosystems. In 2012, Stamets wrote an article detailing how lion's mane mushrooms could be used to treat dementia with their nerve-regenerating properties. He detailed 2 studies that showed promise in that regard. Hokuto Corporation giving lion's mane to 30 patients, and another giving lion's mane to mice with peptide-induced learning and memory deficits. The former took 4 250 mg tablets containing 96% lion's mane dry powder 3 times a day for 16 weeks. Subjects would then be observed for 4 weeks after without any intake. The lion's mane group showed significantly increased scores on the cognitive function scale compared to the placebo group, and after 4 weeks without lion's mane, their scores decreased significantly. The latter was a study on mice with the same amyloid plaque formation seen in Alzheimer's patients. The mice were fed a diet containing 5% dried lion's mane mushroom for 23 days, and were put through the Y maze, which is designed for testing memory. The results revealed that lion's mane prevented impairments of spatial short-term and visual recognition memory. This finding indicates that lion's mane may be useful in the prevention of cognitive dysfunction. In 2012, Stamets also published a study on his mother, an 83-year-old woman that was diagnosed with late-stage breast cancer in 2009, and how turkey tail mushrooms could benefit the treatment of breast cancer. She began chemotherapy with Taxol and Herceptin, and a 4-gram dose twice daily of turkey tail mushroom capsules. 3.5 years later, she is disease-free and still lives an active life today. Stamets' hypothesis is that the turkey tail mushrooms enhance the ability of the patient's immune system, which in turn increase the effectiveness of the chemotherapy. Not only are fungi shown to improve the health of humans, but bees too. In 1984, Stamets noticed bees would consistently sip from the mycelium of some mushrooms that he was cultivating. He wrote about it and moved on. Many years later, he received a phone call from Louis Schwartzberg, a documentary director, asking if he could help the bees. Stamets started thinking of ways fungi may be able to benefit bees when he recalled the strange behavior from before and began researching. What Stamets discovered was convoluted and yet easy to follow once he put the pieces together. The lumber industry in the old-growth forest hired hunters to kill thousands of bears because they were scratching the trees for the resin, in turn reducing the price of their timber. An environmental activist by the name of David Suzuki, among others, discovered bears were pulling salmon from the stream and bringing sea phosphorus back into the forest, ironically making the trees grow larger than they would normally. Within these bear scratches, polypore mushrooms would grow, and bees would be attracted to it. Stamets had a hypothesis that bees weren't being fed a nutritional diet by beekeepers, which typically consists of 50% sucrose solutions. He decided to create a product called Myco Honey, which is created from mycelium with a wide assortment of sugars and polysaccharides. Stamets brought the product to several universities. When he contacted Washington State University, they said, "Please don't go to anyone else. This is too cool of an idea." Fast forward to today, Fungi Perfecti has contributed over $200,000 to fund bee research, and has helped raise nearly $5 million in funding for the Honey Bee and Pollinator Division at Washington State University. Stamets has also helped to create a product called Bee Mushroomed Feeder, which is essentially a bird feeder for bees, allowing ordinary citizens around the world to help save the bees in their local communities. Discovering treatments for incurable illnesses and saving an endangered species? Why stop there? Stamets is a pioneer of using fungi to clean the environment, coining the term Myco Restoration. Myco Restoration has two main techniques of cleaning an ecosystem: Myco Remediation and Myco Filtration. Myco Remediation uses fungi like oyster mushrooms and turkey tail mushrooms to break down contaminants like petroleum, pesticides, and even heavy metals. The process begins by inserting mycelium into the polluted ecosystem. From there, the mycelium will spread its web-like structure through the ground. It will begin to break down the pollutants while also spreading nutrients to surrounding plants, like trees, that they wouldn't otherwise be able to access. Sometimes the fungi will concentrate pollutants, making it easier to manually dispose of. Myco remediation is a great natural alternative to traditional methods of remediation, as excavation and chemical treatment can be expensive and even harm the environment it was trying to clean. Mycofiltration is basically the same thing as mycoremediation, except that it uses the fungi as a filter to clean water. The mycelium is grown onto a filter such as wood chips or straw, and as water flows through, the fungi help break down and absorb the pollutants. Mycofiltration has already been used in many ways, such as stormwater management, wastewater treatment, and agricultural runoff control. Stamets detailed the experiment that proved Myco Restoration could work in his TED Talk, 6 Ways Mushrooms Can Save the World.
The mycelium in the right conditions produces a mushroom. It bursts through with such ferocity it can break asphalt. We were involved in several experiments. I'm going to show you 6, if I can, solutions for helping to save the world. Battelle Laboratories and I joined up in Bellingham, Washington. There were 4 piles saturated with diesel and other petroleum waste. One was a control pile. One pile was treated with enzymes. One pile was treated with bacteria, and our pile we inoculated with mushroom mycelium. The mycelium absorbs the oil. The mycelium is producing enzymes, peroxidases, that break carbon-hydrogen bonds. These are the same bonds that hold hydrocarbons together. So the mycelium becomes saturated with the oil, and then when we return 6 weeks later, all the tarps were removed, all the other piles were dead, dark, and stinky. We came back to our pile, it was covered with hundreds of pounds of oyster mushrooms, and the color changed to a light form. The enzymes remanufactured the hydrocarbons into carbohydrates, fungal sugars. Some of these mushrooms are very happy mushrooms. They're very large. They're showing how much nutrition that they could have obtained. But something else happened, which was an epiphany in my life. They sporulated, the spores attract insects, insects laid eggs, eggs became larvae, birds then came bringing in seeds, and our pile became an oasis of life. Whereas the other 3 piles were dead, dark, and stinky, and the PAHs, the aromatic hydrocarbons, went from 10,000 parts per million to less than 200 in 8 weeks. The last image we don't have, the entire pile was a green berm of life. These are gateway species, vanguard species.
Paul Stamets has shown that fungi are not only crucial for maintaining healthy ecosystems, but also have the potential to revolutionize industries, from medicine to agriculture. As we continue to face a rapidly changing world, it's more important than ever to explore the potential of fungi and other natural resources. Paul Stamets' work is a powerful reminder that by working with nature rather than against it, we can create a better future for ourselves and the planet. His message is clear: fungi can save the world, and it's up to us to embrace their potential.